All right, so this is where we left off. We're looking at the complement rule. It says for some events, it's easier to figure out the probability that the event does not occur. This is the key idea behind the complement rule. For an event A, either A must occur or A prime must occur. Therefore, the probability of A plus the probability of A prime is equal to 1. So let's see if I can straight that here just with a Venn diagram. So you've got one set, and it's disjoint from another set. And let's say this is A, and this is A prime. So um, all the elements in one set are not in the other set. There's nothing that overlaps. And so together they make the entire set of elements. And so if you think of these as probabilities, uh, this could be, say, 3/5, and the other one would have to be a 2/5. Um, and so they would always add up to one. They would always add up to one. So um, I think this was probably an example over here. Let's see. A bag contains balls with the numbers 1 through 100. If you draw a ball at random, what's the probability that you get a number which is not a multiple of 7? We began to discuss this one. So this is a much uh, harder in terms of all the possibilities of things that are not multiples of 7. It's much harder to get at and to count. We could certainly do it because we're only going through 100, but it's much easier to figure out. So this is, I think we're going to call this A prime. So let's just see. Oh, no, no. So they're calling that A. We're going to call that A. That's one thing you have to make sure we're, you have to make sure we're defining things the way they're doing it if they're dividing them for us. Um, so this is A. So A prime are the multiples of 7. So 7, 14, and so on, right? 7 times 3 is 21, 7 times 4 is 28, all the way to 98. And so you can count that. That's pretty easy to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's where we get this 14. There are 100 numbers, so 14 out of 100. We could just essentially use that, but they're reducing, which we're always asked to do, right? So then we know that the probability of A plus the probability of A prime, which is what we know, which is this one, is equal to 1, because you're either a multiple of 7 or you're not. And so this is 7 out of 50. So if I subtract 7 out of 50 from 1, so that's what's happening here, then you're left with 43. of 50, and that's the probability that you draw something that is not a multiple of 7. So here's just another example where you would use this. Um, you randomly pick one of the 26 letters of the alphabet. What's the probability that you do not pick a vowel? So there are, rather than count how many things are not vowels, um, wouldn't be that hard because we know there's 5 vowels, so we know that this is actually just 21 out of 26, right? So we could do it direct with this one, we could do directly, but they're trying to illustrate, look, it's easy to figure out that there are, and to look at and to list the set of 5 vowels. So there are 5 vowels out of 26 total letters. And so if you subtract that from one, you'll find out how many are not vowels. And I kind of prefer this. They didn't do this for the previous example, but we use the prime kind of helps us with the word not. That's not, it's not fixed that you use it that way, but that's the way they're using it in this example. And if you're having to label these things on your own, then um, the one with a prime, the one with a um, apostrophe symbol is the one that indicates not in the other set. Usually, that's how we do it. It's not a set rule, but here's a here's another example. It says storage units are numbered 1 to 50. What's the probability that the operator will choose a unit that is not a multiple of 8? This is from the homework. So things that are multiples of 8 are 8, sorry, are 8, 16, 24. Those are pretty easy, especially since we're only gonna go to 50 to list. They're pretty easy to list. 8 times 4 is 32. 8 times 5 is 40. And 8 times 6 is 48. So there are, 1, 2, 3, 4, 5, 6 things. This is just an index to count, right? So there's 6 of them. So uh, we've got the probability that you are a multiple of 6 and the probability of 8 rather that you're not a multiple of 8 and that's equal to 1. It's supposed to be a 1 there. Let me try that again. You'll find I always get challenged with the writing interface. Um, that's a 1. So this is a set of things that are multiples of 8. And so this is going to be, so the probability that you're in that set is 6 out of 50. And so we're trying to find the probability that you're in A prime. So we'll do it over here. Probability that you're in A prime is 1 minus 6 over 50. Some of these problems will start becoming pretty trivial. So it's 44 out of 50. And so that's 22 out of 25. Or you could convert this to decimal and do 0.88, right? So um so that's how you do that problem. And so that will bring us to the next slideshow. Let me see.